So we're going to do a nonlinear system of equations and inequalities. I don't think we actually get to the inequalities. Do we ever do inequalities? I don't think the homework had you do inequalities. I don't think the book had you do inequalities. Oh, I guess there's one problem here. Yeah, we're not doing the inequalities. I mean, it's the name of the section, but we're just not getting there. So definition, so a nonlinear set of equations occurs simultaneously. It just means a nonlinear system of nonlinear equations. What does it mean? Oops, system to it. I forgot the word non. Is an order set or sets that satisfy all the equations. Most nonlinears are solved through substitution method. Basically, you're just going to solve one equation for one variable, substitute it back in the other, and then get the other value back. This is what you do. It's the only real tool set you guys have that would actually allow you to solve for this. And so here, let's just show you how it's done. I'll do one. I'll have you guys kind of crash through one, and then I'll do the other two. Okay. All right. So here, I have equation 1. I have equation 2. Can I solve any of this equation 1 cleanly for one of the variables? The answer is not really no, right? But for equation 2, I can. And so in this case, let's go ahead and solve it for x, just for kicks, right? So here I'll have, so if I'm going to solve it, I move y over, and then I'll divide by y, so I get 4/3 y. So I just solve this for x. So once I have this 4/3 y, I can plug this into here. So here I'm solving 2 for x, right? So I'm just solving 1 for x, or y, it doesn't matter, right? So here I just solve this one for x. So here I took equation 2, solved for x. Now I'm going to take what I've learned and put it into equation 1. So here I have 4/3 y, or 4/3 y squared plus y squared equals 425. If I square this, I can have 16/9. Remember, you can just pull this in. Y squared plus y squared equals 25. 16/9 plus y, so this would be 1 over, so this would be 9/9. So 16 plus 9 gives us 25/9, or 25/9 y squared. Here I'm just adding these two. So this would be like 9 over 9, same thing as 1, right? So I get 25/9 equals 25. And then here, if I do this, I get y squared 25 over 25/9. So this is the same as just 9, right? Remember, just flip and multiply. In fact, let me do that. Let me do that with you. Let me not skip that step. So this will be the same thing as 25 over 1 over 9 over 25. Remember, if I divide, the same as flip and multiply. These two cancel out, and I get 9. So here, still continuing on, I have y squared equals to 9, which means y equals plus or minus the square root of 9, which is plus or minus the square root of, or plus or minus 3. All right, so here I have two answers, right? So I'm going to plug both those answers back into 2. So here I'll have y equals 3, and then I'll have y equals minus 3. So I'm going to plug those back into 2. Actually, here I've already have it solved, so I'll have x equals 4, 3 over 3. So this is x equals 4. And here I'll have x equal to 4, 3 over minus 3. And so here I'll get x equal to minus 4. And so here I have my two solutions. It's y, or oops, I'll have 4, 3. And then I'll have minus 3, minus 4. Oops, I have that backwards. X is minus 4. Sorry, don't mind my dyslexia. And so I have these two solutions. So let's look at that in Desmos real quick. Desmos, I want to see what these look like, and then I can show how these became solutions. You can do it graphically, and so let's show you how to do it graphically. Desmos.com. Here's a graphing calculator. Here we go. All right, so here I'm going to graph x squared plus y squared equals 25. And so I get a circle. And the other one was 3x minus 4y equals 0. Okay. And so here, it's just the intersection and so here we have nonlinear things, but here we're just looking for the intersection. Here we have 4, -3, and 4, 3. And so we have the two solutions, right? Let's try Wolfram alpha. Let's just try a system of equations. System of two equations. I want to see how smart Wolfram alpha is. So here, we're going to type in these exact same equations. Can I just copy and paste? Would that be just too convenient in life? Oh, I'm a happy man. I'm a very happy man all of a sudden. All right, let's see if Wolfram alpha is smart enough to figure it out. I don't know, actually. I didn't try this. We'll figure it out together, though. Crunch, 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 crunch. It's thinking hard. This should tell you how difficult it is to solve nonlinear equations, because Wolfram alpha is like, no, I don't want to. Come on, you. Think harder. All right, so I'm going to let this think for you as I have you guys try. I'm really curious if that'll ever produce an answer. I know you know how to do it, Wolfram alpha. I just don't know if that's how you want me to tell you to do it. All right, so go ahead and try to solve this. So use this method. Give this one a try for like 3 seconds and tell me where you get to. Okay. My suggestion: use the. I think this book always hands you at least one linear one. Let me double check. Nope, I'm a liar. It doesn't always hand you one linear one. Oh, forget it. I'm just going to do all of this with you. So let's do this. So let's look at this one. So in this case, I'm going to solve this one. Well, actually, we already have one solved. One's already solved, so let's just plug it in. So I'm going to plug 1 into 2. It's already done. So it's x plus 3 minus x squared equals to 5. And so when I do this out, I get minus x squared plus x plus 3 equals to 5. This doesn't factor. It doesn't do anything. So let's just have Wolfram alpha solve it for us. How would we solve this? By hand? We put it through the quadratic equation. All right, so here we're going to solve the following of minus x squared plus x minus 2 equals 5. Okay, so oops, I wrote a 3, didn't I? Oh, it is 3. Never mind. So notice here we get 2 imaginary answers. So in this case, we don't have real solutions. We just don't. So let's. Could you move down the page down, please? Yeah, sure. I'll get there in a second. There you go. So in this case, notice if we were going to put this into a form. Notice we're going to put this into a form that you would type into a quadratic equation. Let's put that in that form real quick, just for kicks and giggles. So I'd move over the 5, so I'd have minus x squared plus x minus 2 equals to 0. And then I multiply by that, I get x minus x plus 2 equals to 0. So this is what you type in the quadratic formula. And so here we get the 2 solutions. So let me write those down. You can crunch that through the quadratic, throw it through the calculator. You get the same thing as you get 1/2 plus I square root 7 over 2 And then you'll have, so this plus or minus square root 7 over 2. All right, in this case, once we do this, I can plug this back into 2. So I can use this, plug it into 2 and get answers. So let's do that real quick. So here I have 1/2. I'll have plus. And so here we have 2 answers. So we're going to plug this into 2 twice. So let's do that. We're going to have x equal to 1/2 plus I square root 7 over 2. And x equals 1/2 minus I square root 7 over 2. So we're going to plug it in back into equation 2 twice because it just goes in cleanly. So here I'll have -1/2 plus I square root 7 over 2 plus y equals 5. And then we'll have 1/2 minus I square root 7 over 2 plus y equals 5. So basically we just minus this from both sides. And so here we'll get y is equal to 9/5. No, 9/2, because a half minus 10/2 give us 9/2 minus I square root 7 over 2. And then here this will give us x is equal to, y equal to, once again, 9/2 plus square root 7 over 2. And so there's the answer. Here's the x, here's the y. You can write this as ordered pairs. We'll go ahead and skip that. So yeah, these get horribly complicated. And notice this only gives imaginary answers. And so if it didn't give imaginary answers, it'd give no answers, if that makes sense. And let me show you why. So here, the first one, we have a parabola. Y minus x squared. So we have some sort of parabola. Let me show you. And then here we just have a line, x plus y equals 5. Oh, hold on, I guess you can't see any of it. And so notice these don't cross, right? These never cross each other, so there's no real solutions or imaginary solution. Yeah, sure. Should I give you this imaginary solution? Honestly, I would just say there's no solution, right? I mean, yeah, technically there's this weird imaginary solution. Technically you know how to do it, but I wouldn't worry too much about it. All right. So most of the time you're going to use substitution method. So I'm going to leave this up for a second and I'm going to show you the next. We're going to do 2 more problems. So notice when I say most nonlinears. Can you solve it using the other method? Yes, and let me show you that. Okay, I'll go back to this page at the end if anyone needs it. You put no solution? I'm pretty sure yes. Hold on, let me make sure I'm not a fat liar. Let me make sure I'm not a fat liar. Let me open up the homework real quick for the section. Preview. La da 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 dee dee dee. All right, so remember the first 1, 2, 3. The first 3 problems you just graph it in Desmos and you give the solution. Here is an order pair, no imaginary, no imaginary, no imaginary, no imaginary. It's radical, but not imaginary. No imaginary. Yeah, there's no imaginary answers in what I'm pulling on the computer, so I guess you just don't worry about it. So I guess it's a non-question, right? Let me rephrase that. It's a great question. So, but it doesn't come up. It just gives you, you're just going to have things which are, this section is going to be interesting to get through the homework. We'll work through it. Ask questions of each other, get through the answers. All right, so let me show you 2 more methods to help you get through it all. So we've done substitution. Yeah, so let's go ahead and do 2 more, and then we're done. All right, so let's do the next one. I was sad that Wolfram Alpha couldn't figure it out for you. Like I said, once it becomes nonlinear, it becomes really interesting. All right, so notice what we have here. What we have here is a system of equations. And notice how this is x squared, this is x squared, this is y squared, this is y squared, this is some number, and this some number. So here, substitution. Actually, here we can actually use elimination. So let me show you this with elimination. We'll use substitution here, but this one, you could use substitution here quite easily, right? Very easily, you can just use substitution. Let me show you that you actually can solve stuff using elimination. Hi, I'm on the complete wrong layer. All right, so let's do this with elimination real quick. And so here, this is going to be equation 1, this is going to be equation 2. I'm going to multiply, I'm going to leave equation 1 and multiply, I'm going to take 5 of equation 2. So we have x squared plus 5y squared equals 39. Here I'll have 15x squared minus 5y squared equals minus 5. Is this? Yeah, this is where I'm supposed to be. We add these two up. I'm going to get 17x squared equals 34 because the y's cancel. That means x squared equals 2. So x is equal to plus or minus 2. Okay. So once I have x equals to plus or minus 2, I'm going to subset 2 into 2. So I'm going to say here x is equal to plus square root of 2. Here I'll put it into 2 again, x. So if you get multiple solutions for x, you're going to have to type it in multiple times into the other one, square root of 2. So here I get x square root 2 plus, or here I'll have minus square root 2. So I'll have the positive version here, the negative version here. I'm going to plug this back into 2 just because it seems like the easiest thing to crunch through. It's easier than this one in my opinion. So I'll just choose the easier of the 2. So here I have 2 times plus square root of 2 squared minus y squared equals negative 1. And then here I'll have, let's just do it one at a time. So positive square root of 2 squared is just 2. 2 times 2 is 4. Is that a 2, guys? That's a 3. I was like, hi, let's do this correctly. So I have 2 times 3, which is 6, minus y squared equals negative 1. So, oops, minus 1. Move the 6 over, so I have minus y squared equals 7, minus 7, or y squared equals to 7. So here we have y equals to plus or minus square root of 7. And so our solutions here are twofold. It's square root of 2, square root 7, and the square root of 2 minus the square root of 7. Okay, so we just solve this through. And then if we did the same thing here, notice we're going to get the same answer. We are going to get the same answer because it'll be 3 times minus square root of 2 squared minus y equals minus 1. We square root the square root of 2, or negative square root of 2, so positive 2. 2 times 3 is still 6, so I have 6 minus y equals minus 1. That means y, because we just literally did this, is equal to plus or minus the square root of 7. So we have our other answers, which is minus square root of 2, square root 7, and then we'll have minus square root of 2 minus the square root of 7. Hi, Doug. And so here we have our 4 solutions. So this is how you do it algebraically. Let me show you how to do it in Desmos, just because that probably a little bit. All right, so let's just do the same thing in Desmos. And so what are we looking for? We're looking for intersection. So I have 2x squared plus 5 y squared equals 39. So here we have an oval, or an ellipse, I guess. technically an ellipse. Technically in math, an oval has straight edges and quarter circles at the end. And the other one was 3x squared minus y squared equals -1, which is hyperbola or hyperbola. I think it's hyperbola. I think it's pronounced hyperbola, and I say hyperbola all the time, which is wrong. And notice here we have square root of 2 and square root of 7, square root of 2, or minus square root of 2, square root of 7, minus square root of 2, minus square root of 7, and then positive square root of 2, positive or negative square root of 7. So we have all the same answers, and so it's just the intersections here. Okay. All right, and let me just crunch through the last one real quick with you. And then we'll call it a day. This is a rough section, but after you do the homework, it doesn't appear in the exam, it doesn't appear in the final. So let's just kind of get through it. Ask me some homework questions come Tuesday or Thursday, and help each other out massively on the little forms. All right, so here we're going to use substitution. Here I'm just going to solve this one for y. So here I have 1 and 2. This time I'll solve for y. So y equals 3 over x. So I'm just dividing out by an x. I get solve for y, plug that. I'm going to plug that into 2. I'll have x squared minus 3 y, which is 3 over x squared equals to 6. Here I'll get x squared minus 3 over, 3 times 3 times 3 should be 27. X squared equals to 6. In order to solve this, you multiply everything by x squared. So I have x to the 4th minus 27 equals 6x squared. Move everything to one side, so I have x to the 4th minus 6x squared minus 27 equals to 0. Here we're going to use the trick where u equals x squared. So I have u minus 6u, or I have u squared minus 6u minus 27 is equal to 0. All right. If I factor this, it's u minus 9, u plus 3? Yes. All right. So that means I have x squared minus 9 is equal to 0, or x plus 3 is equal to 0. It means I have x squared equal to 9, or I have x equal to minus x squared equal to minus 3. So here I'll have x equal to plus or minus 3, and here I'll have x equal to plus or minus I square root 3, because if I take the square root, it's negative. All right, now I have 4 answers here, right? So we have 4 answers here, and so here I'll have minus 3, positive 3. I'll have I square root 3, and then I have square root 3, or minus I square root 3, sorry. And so for each one of these, what I'm going to do is I'm just going to plug this into here. So if I have, so I'm just going to plug it into 1, right? So I have y equals 3 over minus 3. So y equals negative 1 in this case, right? Here I'll have 3 over positive 3. So y equals to 1. Here I'll have 3 over I square root 3. I wouldn't even worry about making this simpler. Just write it as this. And then here I'll have 3 over minus I square root 3. And so here I'm just plugging it all back into the first equation up here.